Answering MCAT questions in under 60 seconds. In an enzyme kinetics experiment, the reaction rate V0 is measured at different substrate concentrations. For a given enzyme, Vmax is equal to 150 nanomoles per second, and the Km is 25 micromolars per second. At a substrate concentration of 50 micromolar, what is the reaction rate V0? Okay, so to answer this question, we need to be able to relate all these variables, and we can do that using the Michaelis-Menten equation, which is simply that V0, which we're trying to find, is equal to the Vmax in the numerator, multiplied by the substrate concentration we're given, divided by the Km, which is that affinity constant, plus that same substrate concentration. So let's plug in these variables, right? So the Vmax, they said, is 150 nanomoles per second. And we're going to write the units here. And that's going to be multiplied by the substrate concentration, which they said is 50 micromolars. That's what we're interested in. Okay? And then all of that is going to be divided by 50 micromolars, right, for that substrate concentration. Okay, and then plus the Km, which is 25 micromolar. Okay, and so notice that then this is going to be 150 nanomoles per second multiplied by that 50 micromolar. I'm going to hold off on doing the calculation there. Divided by 75 micromolars, right? Because 25 plus 50 is 75. And so notice the micromolars will cancel because all our answer choices are nanomoles per second, right? And so here you want to be careful. You don't want to waste time necessarily converting everything into nanomoles when if you realize that the micromolars will cancel. So these will cancel and we'll only have the nanomoles per second in the answer. And then notice that 150 and 75, well, 75 goes 2 times into 150. So this is going to be 2 and this is 1. And then 2 times 50, well, that's simply going to be 100. And then we just have that nanomoles per second. So the answer here is actually just going to be C, 100 nanomoles per second.